Yeah, I just logged into mainframe. So I logged into mainframe and I'm going to use existing library. Okay. So can you all see my screen now?
Now we
Yes,
can.
sir.
Okay.
Yes, sir.
So to see existing libraries or datasets, we have to go to option 3.4, 3, then 4. Okay. If you remember the 3.4, you can directly give here on primary screen, you can give 3.4. So do tab here, it will come here. Here you have to give your dataset name. So I want to see all the datasets present with this name. This is MATAC first qualifier, second qualifier, Krishna dot star. Rest of the qualifiers can be anything. I'm giving star here. So you can see all the datasets present start with these names, with these qualifiers. Okay, so yesterday we have coded our program in this library. Okay, so I'm just viewing. If you want to see others library, we have to open in view mode only. This is called view mode. So you can see view here. So when you want to edit anything, then only go into edit mode. Okay. So when you get like this screen, you can do cancel here. CAN, RCA, and CEL. If you get, it will display you properly. Okay. So this is simple program. To this program, we gave input within the program. We are giving inputs here. So value here we are giving. So this is called a statically assigning values to a variables. So as other than this, we can assign the variables. We can assign the values dynamically. From dynamically means from JCL we can assign the values. Okay. So same thing we can do in by passing data from JCL. Okay. So I'm going back F3. If we press enter, it will come F3 again. So I'm editing now, and let's change the. I'm changing. I want to pass this values dynamically. Okay. So whatever you change in the program, even single character you change, you have to compile that code because we need to generate machine code. Okay. So out of these 3 steps, so we have to code. So we have to change the code, right? Then we have to again compile. If we don't change code, we can execute directly. You can go to third step directly, but we change the program, right? I changed this value. I removed this value. That's why I have to compile again. Okay, because the compilation process will generate the machine code. Machine will understand only machine code. Okay. Hope you have gone through these notes I shared after the session yesterday. Okay, so compile program. This means convert the COBOL code, what we have written. So program whatever we have written, so that should be converted into machine code. Okay, this machine code only the machine understand only machine code. It will be like zeros and ones. This machine code we give in third step as input, then it will come execute that code and will give the output. Okay. So now I change this. Now I have to generate machine code for this. Means I have to do compilation. So if we do F3, it will say so. Just a second. So this is one screen, right? So we can open number of screens on this mainframe panel. Okay. This is one screen. You can see here star means we are on this screen now. On TS list is one screen. If you want to open another screen, do give here start command. So these are there in your I have shared yesterday basic commands notepad, right? That has these commands. Okay. You do start, it will go to main screen, primary screen. So you can see here one more screen is created. So we have 2 screens now. If you do F9 on your keyboard, if you press F9 button, you can navigate, you can switch between those 2 screens, F9, F9 like this. Okay. So another screen, I want to open JCL library. Okay. Or I want to open compile JCL. So my compile JCL is in here make tc dot job lib. So I don't remember complete name. I didn't remember. So I'm just giving j star. So there is only one library with this name. So this is my compile JCL. Okay. So here we have to give the, so yesterday I have given, but yesterday I used view mode. So if you change anything in view mode, it will not be saved. Okay, it was not saved yesterday. We changed this, right? So again I have to give this library name and all. Okay, so here we have our program. This is the source library. So it should have comma here. And our load library name, yesterday we created one load library, right? So it is like Krishna dot load lib. So if I compile again, so it is compiled successfully. Max CC means maximum condition code. So it is 0 means it is successfully compiled. So now I need execution JCL. So I'm doing F3 here, or I will keep it as it is. I will open another screen, start, or okay, I will close this one. I use two screens only. So F3 means going back. So in your view mode, when you are doing F3, it will give some warning. So you change something, it is not saved. Okay. So you can press enter, or you can, if you want to save the changes, you can cancel and you can continue that as it is. Okay. So yeah, I want to change this. I'm in view mode, right? So I want to edit and do these changes permanently. So then that, so I want to copy paste this in edit mode. Okay. So for that I'm giving here command cut. So cut means it will cut all the lines. So 101, sorry, 10 lines cut. It has copied. Cut means copy. Okay, these lines copied here. So I'm going back, press enter here. Now I will edit again. And I will delete this. So our changes were not saved because we were in view mode, right? So now I will delete this old one and I will paste the cut. So we copied there, right? So I'm pasting that again here. I'm saving. So now as I'm in edit mode, now the changes will be changes will happen permanently here. So I did save. So now we going forward, we need to change these library names in this compile JCL. Okay. So now we are done with two steps. Okay, compilation is done now. We have to execute the program now. Okay, third step. So for this, I have to use the run JCL, execution JCL or run JCL we call it. Okay. So we have created one JCL, JCL.lib. So I have created this yesterday, but I didn't use this one. So this is the old existing library, JCL library. So I will take this run JCL. So let me change this one. So when you practice, you create your own libraries like this, and you can you can use the, you can code the JCL like this. So by using the screenshots I shared, you can code the JCL and all like this. Okay. So I will explain what is this JCL and all. So before that, we'll just run the program. Okay. So I'm using existing JCL. Okay, run JCL. So I have to give our library. Okay. Otherwise, I will cut this. Okay. I'm going back. I will use new library. So to explain how to create PDS and all, I have created this JCL yesterday, JCL library, but I didn't use it. So first time when you create any member in the PDS library, you have to use this edit command here, edit, and in bracket you have to mention the member name, run JCL. Okay, so press enter here, you can paste here and save. So here, so you can give high on, highlight on, so it will highlight all these things. So it is for JCL. Yeah, so do high space JCL, it will highlight all keywords in red. These are keywords, exec, DD, and job. These are comments. In COBOL, like on seventh column, star is comment, right? In COBOL program. So in COBOL, this is COBOL, high cob. If you do high cob, you can see keywords highlighted. So columns, if you do columns, you can see column numbers. So in COBOL, column 7 is used for commenting, write the comments here. So you have to keep star to write the comment on column 7. Similarly, in JCL, we have to use column 3 here. Column 3 is for comments, to write the comments. Okay, let's run the program and we'll explain what is JCL then. Okay, so what is our load library now? So our load library is like so mateac krishna dot load dot lib. Can anyone tell what this load library contain? So you can see, right, in step 2, when we compile the program, it will generate the load library, load module. So load module means it will create a member in load library. Okay, machine code. So this machine code will present in load library. Okay, so you can see here source library where we have the COBOL program. So load library, it is to keep the machine code. Okay, so yesterday we have created this library, right, load.lib. So let me check, we compiled right just now. If you so I have opened another screen, third screen. Here you can see 3 screens. So whenever you do start, it will open new screen. Okay, so this is the machine code. It is present in the member inside the load library. Okay, so this member we call it as load module. So this is this member, whatever we give here, pgm1, in this we call it as source program, and the member in this this programs nothing but we can source code. Okay, machine code nothing but this member name we call it as load module, or we can say source modules. So are you understanding how we got this here? Can anyone tell how this is created and written in this library? So in compile JCL, we have given this as output. So this will be the output of compile JCL. So so here we have compile JCL, right? So here this is the output, mateac krishna.load lib. So when it execute the program from this library, so in the program we have in this COBOL library, right? So it will take program from this library and it will compile and will place the load module, means machine code, in this library. Okay, so like that we are getting the machine code in this library, and in run JCL we have to use this machine code. Okay, this library we have to use. Okay, the member, so the member inside the library, it is like pgm1. So here we are telling execute program equal to pgm1. So now we are so requirement is like so this is a program, right? So we need to pass a and b values dynamically. Dynamically means runtime. At runtime we have to pass. So I want for that you have to use here in, so we use JCL, we use a sysin dd star. This is a control, this is called as control card from where we pass the data. Okay. Sorry, there is no space. Sysin dd star. Okay. So here I am passing data like 30 and I am passing 40. So a value 30, b value 40. So you can pass during runtime. So to receive this data in program, so we have to use two verbs that I missed earlier. So we have to change the code again. Okay, I'm editing this program again to add the statement. So we have to do accept A and accept B. So this means this A value will be accepted from JCL. That means it read the data from JCL, this A value. Okay. The first value will be given to A and second value will be given to B. Like that it will happen. So I have to again compile this. So we change this program, right? Added 2 lines. Again, I have to compile. Okay. So this is compile JCL. Again, I have to compile. It is compiled again. So again, this load module will be generated. That means, okay. So now we can execute the program. So generally we can start from this. Okay, if you submit this program, you can see the output. Output, what output we get? We get the output file. Sorry, output as display. Okay, we should get output value of variable C. It is equal to A star B. 30 into 40 we have to get. Okay. So it is successfully executed. So with this job name, we can see the output. Okay, so this third screen we have compile JCL. So I don't need this. I'm going back F3, F3. So if you keep on pressing F3, you can go to finally primary menu. Okay, so here you can go to this options SDSF spool. So here we see the output. Okay, yes. So here we can see all the jobs. Jobs means jobs are used to execute the COBOL programs. Okay, in JCL stands for job control language, right? So simply we call them jobs. Okay, you can see all jobs here, ST. So this is the job we submitted now. So you can give job name, a space show job name. So whatever present, if I do F9, you can switch between these screens. Okay. So if we have more than 2 screens, you can use cursor here. Place cursor on this screen, and if you press enter, you can go to that particular screen. So this is the job name. So behind this job, so beside this job name, job statement, we have job name. Okay. With this name, we can see the output. So I place cursor here, press enter, you can come here. Okay. So here you have to
Sir,
give, yeah.
వేరియబుల్ సికి 3 డిజిట్స్ పెట్టారు కదా సార్, అంటే 12 3 are 12 1200 వస్తుంది.
Yeah, that output I didn't open output yet. So we have to open this.
ఓకే.
So this is just we are checking the job status. We can see this is executed job, this successfully executed. To see the output, we have to expand this job. Okay, question mark if you give, it will expand here. Here in sysort, you can see all display statements. So whatever statements you mention in display is corresponding, this display corresponding DD name, we call it as DD name. So you can see here DD name. This is sysout. So here we get all the messages, whatever we keep in display. So it is giving 000. Why it is giving 000?
Yeah, sir. C variable ni 3 తో ఇనిషియలైజ్ చేశారు కదా. Actually it should be 4.
Okay.
Here third variable.
So we are passing A and B, right?
4, sir. 9 of 4. C variable.
Working store is
Okay, 1200 it will get, right? So this length
Yeah,
should be
4
4. Yes.
digits.
Yeah, okay. So I will change the values here instead of changing the program. If we change program again, you have to compile that.
Compile.
So, yeah. So we'll keep like 200 is fine. 2000 we get, right? So if I run again, yeah, good catch on that. So it is again giving 000. So this position sometimes it matters. So we have to give it starting position. So it is taking only this, start counting from this. I think it will take from this. So let's run again and see. It's giving 2. What should we get? 200, right? So what variable we have given to that? So we are giving 9 only numeric. So there is a concept of justification. So for numeric data, so data will enter from right to left. If we give 10, so it will take 10. So if I give only 1, so it will take like 0, 1. Like the data will enter from 1. For alphanumeric, data will enter from A. So if I give just A value, if it is x of 2, if we just give some value like from the name Krishna, if I give only K, it will take first character, first byte it will fill with K, second byte it will fill with space. Okay, like that. So it is, it should take from right to left. Not sure why it is giving like that. So this in-stream data position based on this also it will react like that. So we'll see whether we should start from column 1 or column 2. So real time we don't use this general. So let's try this way. This is explained just to make you understand the how we pass data dynamically. Okay. So okay, it is working now. Okay, this position, it is counting data starting from first column. Okay, so it is taking, so we have 2 bytes, right? A length is 2 byte, 9 of 2. Accept A, so it will accept a value for these 2 bytes starting from this first column. Okay, so 1 2 like this it is accepting. So when I give here 1 2, it is only taking. So when I giving, as earlier we gave just this, right? So it took like 0 1 space 1, like 0 1 and 0 2. Then it's, and that's why it is giving 0 0 2. Okay, so this is the way we pass the data into the program from JCL. So I'm passing these values. This is JCL. Okay, from this JCL, I'm passing data to this program dynamically. Dynamically means So we can run time. So I can pass any data. And I don't need to change the program. Without changing program, we can pass anything any number of times. So if I give like 9 to 3, for example, if I give like this, so it will. So if we give like this, it will truncate the data. So we have given the length of C is 3 bytes only, right? So one digit will get truncated. So if you run this, you can see this output as this. So instead of 2700, we are getting only 700. Okay, because the length of C is 3 bytes only. Okay, so left right justification means data will data will be entered from right to left. Okay, so it will take the data. So this is the value, right? So into those 3 bytes, 1 2 3, so it will data will be entered from right side. So only it will take first, it will take 0, next it will take another 0, next it will take 7, and next these 3 bytes will be filled, then this 2 will be ignored, like that. So for numeric data, it will happen like this. So least here you can see this leftmost digit is truncated. So like this, we can give any number of times we can run the program by just changing the values here. Okay, we are changing the values at runtime. We are not changing anything program. Okay, so based on requirement, we have to decide whether static value we can pass. If you give static value, you cannot change that. So if you means you cannot run that directly. If you give some same value like 30 and 60 like this here. So and then you don't need this. So what is the drawback is here you can run this program only with these values. If you want to run with some other values, you have to change the values again. Every time whenever you change the values, you have to compile the program. So compilation is mandatory in static assignment. When you do dynamic, so at the time of execution itself, you can change the values. You don't need to compile the program again. Okay, that's the difference. And we'll see what is JCL. So we'll explain what is JCL. Okay, JCL stands for Job Control Language. Okay, so similarly, it is also structured language. So how COBOL has divisions, sections, paragraphs. So COBOL has things like this, right? Sorry. So divisions, under divisions we have sections, under sections paragraphs, sentences or statements and verbs, like that. So if you did see, this is simple program. Here we are using identification division. Under this we are using just program ID. This program ID also we call it as paragraph. Only in this division, this is treated as paragraph. Okay. So data division we are using second division, and under data division we are using working storage section. This is for temporary variables. We use this section for variable declaration. So these variables I use in activities, whatever I do in procedure division. Okay, here actual execution will start. Okay, so this is the operation, and I'm computing, I'm displaying here. So like this division, under division paragraph, under division section, so under division, these are statements directly, no sections are there.
Sir, one doubt.
Yeah.
ఇక్కడ వర్కింగ్ స్టోరేజ్ లో 0 1 అని పెట్టారు కదా, అక్కడ 0 1 0 2 ఏమైనా తీసుకోవచ్చా, లేకపోతే కాన్స్టాంట్ గా ఒకటే తీసుకోవచ్చా?
ఎన్నైనా తీసుకోవచ్చు. So this, the purpose of this is, for example, let's change the program. So I want to display some name. Okay, along with this, I want to display some name. Let's say full name. Full name is x of 10. Okay. X of 10. So under this, I have first name. Yes, yeah. First name 5 bytes and second name 5 bytes. It can be anything, but so here like this you can code here. This picture class is not mandatory here. So it is this 01 level is collection of these two. Okay, this total of these two 0505 length should be equal to this 01 level variable length. Okay, so you can only to code here pick name, pick x of 10. So automatically, so total of this combination of this first name and second name is equal to nothing but full name. Okay, so that is the purpose of this level numbers. So like that you can have some other levels also. You can have like 10. For example, if it is address, you can have some again house number, pin code like that. So second name, if you want anything, something second name is also contains surname. If you want to separate that, you can have something like second name first 2 bytes. You can say something like I want to something I'm giving. So first 2 bytes you can use for different purpose, and you can. So otherwise I can just give part 1 second name, part 1 2 bytes, and part 2 it can be like 2 bytes again. So if you do insert, you can have use the command R also. R means repeat, it will repeat the line. So part 3 it is 1 byte. So we have name like this. So this is not optional now. You need no need to mention this exactly this length. Okay, you can remove this. So it will look like this. So if I display full name, it will display all these things. Okay, full name contain first name, second name, and second name contain part 1, part 2, part 3. Okay, like that. So if you let's pass some value to this first name here. So to pass anything, we have to use statement move. Okay, move means moving some value, some name to this. Okay, let's move some something name. Let's move SV technologies. Okay, what is this length? So total length we have 10 bytes only, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we'll use mainframes, MAN or MMC. So 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. Okay. So I am passing this value to this first full name variable. Okay. This is a variable. Move to variable name. This is the way we pass the values in COBOL. Okay. So if I pass these first 5 characters, main F will go to first name. Next 5 characters, they will go to second name, and part 1 will get 2 bytes from next 5, and like that it will happen. So if you display, I'm inserting display here. Display. I want to display all names like first name, full name. Sorry, full name. If you put in quotes, it will display as it is. Okay. Then variable. If I give variable name, it will display the variable value from variable. Okay. So I will have 1, 2, 3, 5 displays. So I'm repeating this line 4 times. R4 means 4 times it will display. So display first name, we want to display second name, so each statement will end with period. This is called as full stop is called as period. So in COBOL, in general, each statement will end with this full stop, that is called as period. Okay. So part 1 will display. Then part 2. Then part 3. Okay, so I'm displaying all these names. Okay, let's compile this program and execute this. So we change the program, right? We have to compile to generate the machine code of this source code. Okay, so I have to open the compile JCL. So screen 3. So star means we are at screen 3 now. So I'm opening screen using screen 3 to open a compile JCL. Okay. Here from main screen 3.4 again. So mate ac.j J star. Here I have job lib library. In this I have compile JCL. Okay. So here same program name. There is no change. Same program, same source library and same load library. Okay. Successfully compiled. Then we have to execute the program. Okay, this is same program. Let's execute. I'm even passing values, some values, so we can display all these things. So I'm submitting again. I'm opening another screen. Start new screen. Okay, it compiled successfully, executed successfully. So spool status of jobs. Generally, last job will be our last executed job. So we can directly open this question mark and system. So you can see here the output. So what we have: full name, mainframe, first name, first 5 characters, first name, right? So main F, first name. Second name, it is like RAMLES, second part of the name. And part one is from second name, first 2 bytes, part 1, RA. Okay, in second name, third and fourth byte, part 2. And last 1 byte is part 3. Like that, the assignment will happen. So that is the advantage of level numbers. Okay, any doubts or is it clear?
Okay.
So like this, we have level numbers from 01 to 49. So depends on requirement, we can use. So we can use directly 01, 02 also. Instead of 05, we can use 02 like this also. We can use anything, but as we have a lot of numbers, generally we use as per standard 1, then use 5, then use 10, then 15, 20, like that we go. If there are more variables, more levels we require, then we can, in that case we can go for 01, 02 and 03, like that. So this means these two are on same level. 5 means these variables are on same level. Okay, 10 means these 3 variables are at same level, like this. So here 01 means these are all same level. So 01 is generally we use this for group variables. This is called group variable. These are all sub variables, right? This is a group variable. These are all sub variables. So these are all independent individual variables, we can say simply. So you can, if we want, you can have sub variables under this variable also. Then that case, it will be called as group variable. Okay. So how much time we have? Okay. Yeah. Let's discuss about JCL. So anyone has any doubt on this program?
No, sir.
Okay. So these are simple statements you use. Okay. To pass, to assign a value, we have to use move statement. Move means moving this value from. So whatever you keep in quotes, that means this is treated as constant. It is moved as it is. If you want to do variable to variable move, you have to mention variable name here instead of this. Instead of this. So if I want to move first variable, sorry, what is that? Second name into first name, you can use the variable name directly. It's like this: move second name to first name, like that. This is moving from variable to variable. This is moving some constant value to a variable. Okay, so you can also move like that. Move A to B, variable A to variable B. Also, we can move like this. So simple statements we have: move, display, accept, compute, like this only. So there will not be like more than 15-20 variables. So you just need to remember what to use, the syntax. These all look like English words only. Okay, so it is like for whoever don't have computer knowledge, this is not required. Like why, while like, so when you learn C language initially, so that is you are new to C language, so you don't know computer. So like how they explain like what is data type, what is variable. Same way, this is COBOL is also starting phase. You can start directly with COBOL. You don't need to have OOPS concept. You don't need to have knowledge of anything else. Prior knowledge is not required for this. Okay, so let's discuss about JCL. So like how we have structured programming in COBOL, same way we have structured programming JCL. Okay, so this is JCL structure. JCL stands for Job Control Language. So to run anything on mainframe system, we need JCL. Okay, so I will use the same and update. So to run anything on mainframe system, we need JCL. Okay, run means nothing but to execute. So here it will have three statements, three level structures we can say. One is top level we have job. Under job we have exec statements. Under exec statements we have DD statements. Okay, you can see here job. Under job we have step one. Step one executing program one, and it has DD1, DD2. So these DD names are used to mention the file names, input file to the program or output file from the program. Like that, whatever files we use in the program, we refer in the program. Those files we have to mention in this JCL. Okay, this file concept is not yet started. I thought that I will start that today. So okay, we'll start that from tomorrow. The files, how we read files and how we write data in files. Tomorrow we'll start that. So and you can see step one, I'm using running program one, and under that you can see step two. Step two, I'm running program two, and step two has its own data sets, DD1, DD2. Data sets means these are like PS data sets. PS datasets, I told right, they are like same as Excel sheets. Like how we have data in Excel, same way the data present in PS file. So that files we mention in JCL under step names. Under the exec statement, we mention in DD names that file we mention. Okay, file names we mention. So step 3, like that, you can see job is a collection of steps, and a step is a collection of DD statements. Step is nothing but exec. So I can say simply. So job is it has 3 statements: one job statement and 2 exec statement, DD statement. Exec statements, exec is also called as step. Step, we call it as step exec. Okay. So JCL has basically 3 statements. Job statements. Okay. It is a collection of exec statements. So exec statement, we call it as step. Okay. So exec statement is nothing but is a collection of DD statements. Okay. And DD statements are like last statements. So where we mention the files referred in program. Okay. By files means nothing but PS datasets. You can call it as PS datasets or simply files. Okay. Referring program. So we mention here in an exec statement, we mention program name. Program name to be executed. Okay. So if you see the JCL here, so this is our program, right? So we mention the program name on exec statement. So job is a job. So each JCL has one job statement. So under the job day statements, it has exec statements and DD statements. Okay. So on exec statements, so we mention the program name here. PGM equal to, this is a parameter. PGM equal to program 1 is a program name, like that. So on DD names, we mention the dataset name. It can be PS or PDS. If it is data, we are reading data, then that case we give PS file. Sometimes we can give PDS also. So here you can see this is a PDS library, right? So we have predefined DD names. So this is a DD statement. So whatever present just beside these statements, we call it as their name. Like, so it is job statement, right? This is called as job name. This is exec statement. This is called as exec name, or we also call as step name. Okay. This is DD statement. We call it as DD name. Okay. So they are identified with the names. So they are called with the names. 8-byte names, we have those names. So 8-byte names mentioned beside the statement, beside the keywords. Keywords like job, exec, DD. Okay, so example, job name, job, like that. We have exec name. So instead of exec name, we call it as step name. Okay, step name, exec. Exec is a statement. And DD name, DD. Okay. So this is job name, job. So this is step name. We call it as exec also. We can call it as step. So this is step name. This is exec statement. This is DD name. This is DD, and this is another DD name. This is DD parameter of that. Like that. This is DD name. This is DD. Like that. This syntax, the notation will be like this. So whatever present adjacent to that, we call it as that name. This job name. This exec step name is this one step name. Whatever we code this. Okay. Here the step name is step 01 is step name here. Here step lib is DD name. Sysout is DD name. Sysin is DD name. Like this. Okay. So we have default predefined DD names. Step lib. We have few predefined DD names. So you can see here predefined JCL DD names. Okay, these are the predefined names. Okay, in every JCL we can see these are common. Okay, so step lib. So step lib, job lib. These two are used to mention the load libraries. So step lib or so step lib or job lib. These two are used to mention the load libraries. Load library. Okay. So load library means it is nothing but compilation output which is having machine code. We can say load module. Load module, it contains the machine code. Okay, so here I am using step lib DD default DD predefined DD name. Here I am mentioning this load library. This load library contain. If I open this, I'm going to make another. I'm opening another screen. Start, press enter, open another screen. I want to open this library. So 3.4 directly. So 3.4 means you can see existing library, right? I'm giving this, you can see this. So this is called as load module. Okay, inside load library, we have load module because it contains machine code, right? That's why we call it as load module. Here in COBOL library, we call it as COBOL library and we call it as source module. Source module means it contains the source code. This is the source code. Like the terminology you have to habituate. So while you prepare, when you practice, you will remember those things easily. Okay. So here we mentioned this. So other than this, we have default DD names. Sorry, predefined DD names. Sysout, sysprint, sysdump like this. So sysout we use. Sysout is used to display the messages. So is it used to display the messages, whatever coded in the program. Okay. So whenever you use display statement in the program, so those all messages will come into this sysout. Okay. So we have seen right just now. So this is a job. This is job name. So I said right. This is job name. Mate ACZ and a job name. So here mate ACZ is a job. This is job statement. Okay. It is moving with cursor. So this is job statement. This is job name. Okay. So you can see the entry here, job name. So this is job name, and each job will get one ID generated. Whenever we submit, it will get one ID will be assigned to that job. Okay. So and if you expand this, question mark. If you give under this this keyword, if you give question mark behind this job name, it will expand this DD names. So these are also default DD statements. So they are present only in spool, we can see. So we have these also we can consider the default DD names. So all display messages we can see under sysout. Sysout means system output. Okay. So sysout of step name. Step name. What is step name here? Step means I said right. It is a step. Exec is a step. Step name means step 01 is a step name. So you can see here step name. This is a step 01 is step. Step 01 sysout system output. So I can see here by giving yes option. Okay. So here we can see all the display messages. That is the purpose of sysout. Is used to display messages whatever coded in the program. Okay, so like that. Okay, we are running out of time. I will stop with this predefined names. So we have sysprint. So here it will print the system messages. So any mainframe the program related message other than sysout messages which we don't display, they are all printed under sysprint DD name. Like that we have sysdump. If there is it will print. So it is used, you can say it is used to print error messages. If a job fail, or we can say when the job failed, error message will be printed under this sysdump. So I will explain these other parameters in next class. Okay, so can remember these things till now. So it is used to print system messages other than display messages. Okay, so these are the predefined GD names we use in JCL. Okay, so we'll discuss about compile utility and all next session, and we'll also start with files in next session. Okay. Okay, thank you all for joining. Anyone has any question? Yes, I will share these notes and just go through this, read, and let me know if you have any questions. Okay. Okay, I will keep sharing recordings. So if you have any doubts, you can go through the recording if I am going fast. Okay. Yeah, if you understand 1, 2, 3 classes, then from next class onwards, you will become familiar with these words and all navigation and all. So if you practice, then it will become easy to understand how I am moving. So I request you to practice once, then you can follow easily. Thank you all for joining. We'll connect again tomorrow. Bye.